Modern aviation technology can detect water droplets from miles away in the sky, but here's what's wild. It completely misses clouds and fog that we can see with our naked eyes. The limitations of weather radar systems reveal a fascinating story about how pilots navigate through some of nature's most powerful forces.
That's such an interesting paradox. How can something so sophisticated have such basic blind spots?
Well, it comes down to the size of the water droplets. The radar works by measuring reflectivity, and get this, a water particle reflects 5 times more than an ice particle of the same size. But if those particles are too small, like in clouds or fog, they're essentially invisible to the radar.
Hmm. So, how do pilots actually interpret what they're seeing on their displays?
It's like reading a complex map where red means high reflectivity and green means low. But, and here's the crucial part, those colors can be deceiving. A storm cell showing up as green might actually be incredibly dangerous if it has massive vertical expansion.
That reminds me of the blind alley effect you mentioned earlier. Can you explain more about that?
Oh, exactly. Picture this. You're looking at your radar display at a short range, and you see what looks like a perfect path through some storms. But when you zoom out to a longer range, bam, you realize you're heading straight into a dead end of severe weather. That's why pilots typically keep two different range settings, 160 nautical miles for the monitoring pilot and 80 for the flying pilot.
Well, that's fascinating how they use multiple perspectives to build a complete picture. What about these ice crystals I've heard about?
The ice crystal situation is particularly sneaky because they're almost invisible to radar. You might not even know you're flying through them until you see what looks like rain on your windshield at temperatures where rain shouldn't even be possible, like negative 40 degrees Celsius. And these crystals can cause serious engine problems, even though they don't show up as a significant threat.
So, pilots are essentially dealing with invisible threats while managing the visible ones?
Exactly right. And here's another layer of complexity, something called attenuation. When the radar signal gets overwhelmed by heavy precipitation, it creates these storm shadows behind intense areas. Experienced pilots actually use these shadows as another clue about storm intensity. If you see a black hole behind a red area on your radar, that's actually a warning sign of a very active storm cell.
You know what's really striking about all this? The way pilots have to combine all these different pieces of information to make split-second decisions.
And that's where the real expertise comes in. Like pilots use this fascinating formula to calculate storm height. If a weather return disappears from the radar at 40 nautical miles with a tilt of 1 degree down, that tells them the storm top is precisely 4,000 feet below their altitude. It's like doing geometry in 3 dimensions while moving at 500 miles per hour.
That level of precision is remarkable. How do they handle situations where the radar might be giving them misleading information?
That's where experience becomes crucial. Near the sea, you might get very reflective clouds that look dangerous, but aren't actually a threat. But in equatorial regions over land, you could have extremely dangerous storms that barely show up on radar because they contain less moisture. That's why the golden rule is to never underestimate a storm cell with high vertical expansion, even if it looks relatively weak on the display.
So, in the end, it's really about combining technology with human judgment?
Absolutely right. And you know what's really interesting? The standard practice is to stay at least 20 nautical miles away from severe storms. But pilots are specifically taught to prefer deviating upwind rather than downwind. There's usually less turbulence and hail on the upwind side. It's these small but crucial details that make the difference between a smooth flight and a dangerous situation.
Looking ahead, what do you think this tells us about the future of aviation safety?
Well, while we're seeing amazing advances like predictive wind shear detection and automatic tilt control, the fundamental principle remains unchanged: respect for nature's raw power. It's a perfect example of how technology doesn't replace human judgment, it enhances it. And that's really what makes modern aviation so fascinating, this constant dance between cutting-edge technology and the timeless wisdom of experienced pilots.